Hello friends, and welcome back to my channel. Today I'm going to be looking at how to evaluate limit of a function. So I have this question here. Evaluate lim x tends to 2, x squared plus 4x minus 12 divided by x squared minus 2x. Now, first thing I need to do here, so I need to replace x here with 2 to check if I'm going to get an indeterminate value. So I'm going to say 2 exponent 2 plus 4 brackets 2 minus 12 divided by 2 raised to the power of 2 minus 2 times 2. So replacing x with 2, I'm going to get this. Now simplifying this, I'm going to have 2 squared is 4 plus 4 times 2 is 8. So 4 plus 8, that's going to give me 12. 12 minus 12 is going to give me 0. So 2 squared divided by 2 squared is 4 minus 2 times 2 is 4. 4 minus 4 is 0. So this is an indeterminate value. So I need to do something here because this is not the final answer. This is not the answer at all. So I need to do something here. There are two formulas I can use. The first one is factorization. The other one is using differentiation. That's the hopital rule. I'm going to write it here. Or rather, let me write it here. Le hopital. The hopital rule. Okay, this is the second formula I'm going to use, the second method. But the first one, I'm going to factorize this expression, both the numerator and the denominator, and replace x with 2 again to check if I'm going to get indeterminate value. But if not, that becomes the answer. So whatever I get becomes the answer if I replace after factorizing and I replace x with 2. So, and it's not 0. So that would be the final answer. Now, I'm going to say, look for, this is a quadratic expression. The numerator is a quadratic expression. I'm going to look for two numbers that will give me plus 4 if I add them, but will give me minus 12 if I multiply them. What are these two numbers? I might consider minus 2 and plus 6, because minus 2 plus 6, that is going to give me plus 4. But minus 2 times plus 6, that is going to give me minus 12. So I'm going to write x square. So in this case, I'm going to replace the middle number, which is 4, with the two numbers. So I'm going to have, I say minus 2. So remember, we're dealing with a variable x. So I'm going to write minus 2x plus 6x, then minus 12. You can see the middle number or the middle term is gone. So it's replaced by these two numbers. Now divided by, that's how to do factorization. Divided by, so I'm going to factorize the denominator as well. So factorizing the denominator, remember x, this is x squared minus 2x. X is a common factor, so I'm going to write x bracket x minus 2. Because x times s is going to give me x squared, and x times 2 is going to give me 2x. Now, going further, I'm going to factorize the numerator. I'm going to say, if I put brackets here, and put brackets here, I'm going to look for a common factor between x squared and minus 2x, and that's x. I'm going to bring out x. I'll put brackets here, I'll have x here remaining, minus 2, then plus, then 6 will be out because this is a common factor between 6x and minus 12, or rather 12. I'll put x here, minus 2, because 6 times 2 is 12. So you can see this and this are common. I'm going to pick one. But remember, we have a denominator. So I'm going to write x bracket x minus 2. So in this case, I'm going to pick one because they are common, x minus 2 and x minus 2. I'm going to pick one. Okay, because they are common. So I'll pick x plus 6. Okay, and x minus 2. Then divided by x bracket x minus 2. So in this case, this is going to cancel out this. I'll have x plus 6, x plus 6 divided by x. Now, I'll come back to here where limit is x tends to 2. So I'm going to replace x again with 2. So I'm going to say 2 plus 6 divided by 2. Remember, 2 plus 6 is 8. 8 divided by 2 is going to give me what? 4. So this becomes the answer. Okay. Now using the second method, which is the hospital rule, I'm going to differentiate this expression, both the numerator and the denominator. So differentiating the expression, I'm going to have, you know, the formula for differentiation. The formula is this: n a x exponent n minus 1. This is the formula where n is the exponent or the power of the variable. The variable here is x. A is the quotient of the variable. So I'm going to say 2 times 1, and here, this first expression, x squared, the quotient of x squared there is 1. So I'm going to say 2 times 1. That's going to give me 2. Then I'm going to write 2x. I'm going to write 2x. Then 2 minus 1, that's going to give me 1. So it's supposed to be 2x. That is the derivative of x squared. Then I will do the same here, 4x. So when I differentiate 4x, I'm going to get 4. Using this formula, I'm going to get 4. So when I differentiate minus 12, minus 12 is a constant. And anytime you're differentiating a constant, it's going to be 0. Okay, divided by, I'll do the same here, x squared minus 2x. Differentiating x squared, I'm going to have 2x. Differentiating minus 2x, I'm going to have minus 2. Okay, using this formula. Now, you can see I have 2x plus 4 divided by 2x minus 2. Now, remember that lim x tends to 2. I'm going to replace x here with 2. So this is going to be 2 brackets 2 plus 4 divided by 2 minus 2. So 2 times 2 is going to give me 4. 4 plus 4 is 8. 4 plus 4 is 8 divided by 2 times 2 is 4 minus 2. That's going to give me 2. 8 over 2 is going to give me 4. So this is the hospital rule. Very short and simple. You can see I have 4 here and I have 4 here. The same thing. This is first method. First method. This is second method. Second method. So whichever way, you're going to get the same answer. But remember that when you replace an initial equation or function, sorry, not equation, initial expression, when you replace x with 2 and you're getting 0, that's in the indeterminate value, you need to either differentiate using the hospital rule or you factorize to get your answer. And replacing x with 2 again, you're going to get your answer. Thank you for watching.